Hello class. Today we will discuss about AWS containers. Like what are containers in AWS especially because we are talking about the AWS cloud. As you know, there are multiple clouds these days. There is a Google Cloud and Azure and AWS. So we are talking about AWS cloud specifically and as a service of AWS. We'll talk about containers on AWS. So basically, containers are nothing but a small part of the application that is independent of the operating system. That is what is the basic definition of a container. So container is actually, if you just go as a layman, so you can just say container is a type of application only. It's a independent form of an application which can be ported to any kind of an environment. Could be a test, could be a prod, could be a laptop, could be a desktop. So today's agenda is like what we have to talk about is what are containers, what are the containers on AWS. So what are the different type of containers on this specific cloud? We are talking about AWS, and what are the advantages of running the containers on AWS, and what are the different hands use cases, like where do we actually use the containers, and lastly we'll see the hands-on session. So I told you like what are containers. So if you want to read the definition, so containers are basically an executable unit of a software in which application code is packaged along with its library and dependency. So as I told you, it is actually an application only, but it is not depending upon the operating system. Like what do I mean to say here is like every time whenever you have created an application, you need to have a Linux operating system or maybe Unix or maybe I mean if you talk about a lighter application, so Windows could be any operating system. Without an operating system, you are never able to create an application. So over here, what we are doing, we are creating an executable. We are creating an executable form of an application which is independent of the operating system. And what are the advantages of that? The basic advantage is that this kind of an application is a super light and super durable. I mean, it's a very lighter form of an application. You can just port it from one platform to another platform as and when required. And you can have an economy of scale also. I mean, in spite of suppose earlier we used to have three applications on one operating system. Now we can have 1,000, 10,000 applications the um, on the platform that supports the containerization. So I think I have made you understand the definition of a container. All right, class. So, what happens is earlier we used to have the concept of virtual machines, and now that concept has been, I mean, it's been slowly being getting replaced by containerization. So, what is the big difference between virtual machines and containers? So, understand this carefully because this is a very important question from interview point of view also, and from your understanding point of view also. So what used to happen in virtual machines? Just see here. What used to happen? We used to have an infrastructure. We used to have a host operating system and a hypervisor. Hypervisor is a software layer between the connectivity of the application and the host operating system. And we used to have a guest operating system. So in the virtual machine, suppose you are working on a virtual machine, so you will always have a guest operating system on top of which the bins and libraries are attached, on the top of which your application runs. But over here, when you talk about the containers, you have the infrastructure, you have the host operating system, and then you have the runtime environment. So what do I mean by runtime environment? This is the basically this makes the container application independent. So this runtime environment associates with bin and library, and it can be supported on any kind of a platform. So that's what is missing in a container. So when the guest OS and the hypervisor is out of the container infrastructure, this is what it makes it super light and super durable, so that the containers can be ported into different kind of environments like your local laptop, your staging or QA environment, your prod environment, or your on-prem environment, wherever you would want to be associated with to that container. So now we come to the next thing, which is containers on AWS. So how do we work on the containers on AWS? So coming to this, we have three things. We have three categories on which we work on the AWS in the containers. First is the registry, second is the orchestration, and third is the compute. Now understand what are these things. So basically what happens is that I'll just make a small drawing in case I'm not able to find it here. Yeah, so what I will do is, see, this is my container application. These are the small containers. These are the small containers in my platform. Okay, these are how you keep the containers. So now you know that containers are small applications, and they are the executable applications which are not depending upon any kind of a operating system, and they have the libraries, and the runtime environment is packed into this application. So these small things are called containers, and the outside this thing is called as Docker. So basically, Docker is a platform which holds this entire thing. So fine, Docker is a platform which holds these containers, and you can just load your containers into these Docker as much as Docker, I mean, as much containers you want. So you can have, let's say 10, 20, 30, or maybe 100. So I mean, there's a scale, there's a economy of scale. I mean, you can scale as much as possible. I mean, there's a concept of scalability over here. So this is how your container and the Dockers look like. So now, coming back to this point, what are the various services? So basically, first of all, I'll tell you that what is the, so I think now you understand the difference between Docker and container. So I'll just tell you one more thing, that the Dockers can be controlled with the help of three things. I'll just write here, one second. So I'll just choose a new one. Don't save. So uh, Dockers can be controlled with three things. You can have a CLI, that is command line interface. You can have a REST API. You can control your Dockers through REST API, and you can also, it's, I mean, you can write the code. So what I want to say over here is that once you have this Docker and you want to put your containers into that, so you have this command line interface, and you have this kind of a, interface to check that which kind of containers will be associated with this particular Docker. So like you manage your Unix system, so suppose you are working on a Unix, so you have some command line interfaces, you have some command copy, run, MD, CD, to keep on creating your files and directories, and keep on copying from one location to another, or maybe moving your file. So similarly for Dockers also, so whenever you want to put your containers into the Docker, you have a command line interface kind of a thing. So over here, we have three things. One is orchestration. What is orchestration? Okay, so I'll tell you that, because I showed you the diagram that inside the Docker there are multiple containers. So the question is that when there are so many containers, how do you manage those containers? How will you manage? I mean, what will you do to manage? Suppose you want to remove one container, or you want to scale up one container, or you want to update another container, like we do with our files. So how do you do? So that is called as orchestration. All right. So how can we do this orchestration? Orchestration is, in simple words, it's like management of containers. So how can we do orchestration? There are two services, ECS and EKS. We'll study that in detail in the next slides. So ECS is your Elastic Compute Service, and EKS is your Elastic Kubernetes Service. So Kubernetes, you must have heard this word Kubernetes a lot. So we'll understand the difference between these two. Second, one more service about containers, one more categories of containers is about your EC2 and Fargate. So what does this mean? That means you can have your containers. I mean, you can have your containers on a EC2 platform, or you can have on a Fargate. So what I mean to say is that, suppose this is my paint. So this is my paint. I'll take a new file here. So this is my Docker, and inside that it is containers and all. So I want to place this somewhere on a virtual. I want to have a server kind of thing. I want to put this entire structure, this containers and all these things. Underlying thing has to be a server. Okay. So on a server, you will have all this kind of machinery design and everything. So what happens is that in AWS, you have two kind of things. One is your Fargate and another is your EC2. So basically, either you can put your containers on a server technology, or you can put your container on a serverless technology. That you want your containers to be managed with some background processes, and you don't want to get into the hassle of creating a server space for it and understanding the CPU, the memory utilization, and the networking part of it. So when you are putting your container and the Docker on a server, so that type of a setting is called as a EC2. Because on EC2, that means you are asking for different kind of virtual servers. You are trying to create different kind of virtual servers from the AWS. And once you create a virtual server, then you have to do everything. Like you have to create firewalls, you have to understand how much my server will be, what space my server will be, what kind of server will it be, and what kind of networking will happen, what kind of storage, where the server will be stored. So you have to take care of so many things. So over here, your management your management as a user, your responsibility will increase. On the other hand, in case you do not want to get into this, you do not want that I want a EC2 instance before that. So that time, what you can say that okay, I just want my Docker, and on the top of that I want my containers. Okay, and in these containers I do not want a virtual server, or I do not want an EC2 server, but I want this to be managed with the help of some background processes. So that type of setting is called as a Fargate. This is a new service given by AWS. Fargate is a service in which you do not involve any server settings. You do not involve any servers, any CPU, and the hassle of having a server, its CPU, managing the CPU and all. So you just say that okay, I do not want that on whatever platform it is running, on whatever server it is running. I do not want that. I just want to manage this kind of a scene. I just want to have this scenario in which I am just managing my containers. So over here, this kind of a technology, the background processes will be managed by AWS support team. They will not tell you what they are doing, but you will know that it is being handled somewhere in the background with the help of the AWS team. You will only manage your this particular containerization. So this kind of a management, this kind of a orchestration is called as a Fargate orchestration. Now I'll come to this registry process. So what is registry? All right. So what happens is, now understand that registry part is like, how, okay, I'll just try to explain it in simple words. What happens is that inside the Docker, when you are putting a container, basically the containers are the read-only images. Read-only images means that once you have created a software executable, and then that executable can be only updated by you. It's not like suppose you have created a container and I am also able to update your container. Third person is also able to change your container. Fourth person, anybody who comes in, he knows okay, this container name is ABC, and I am able to change second person. So no, that is not the process. It is like it's an immutable copy. Immutable means it's a read only image. So what happens is, registry is a ECR service. It's called as Elastic Compute Registry. So basically registry is that whatever the number of images that you are creating, you are those are getting registered in your this ECS registry. So whatever the number of images of those containers that you are creating, they will be able to, you will be able to create that through your ECR service. So this is what is your registry. So now what happens is, I'll tell you that, once you are trying to create containers on AWS, you have now different type of, you have understood that you can create containers, you can manage your containers. You can manage your containers by having a virtual server or maybe a serverless technology. So either thing you can choose. Now what happens is, whenever you are creating your containers, you need to have a task definition. What is a task definition? It is nothing but actually it is a service that you will write. So once you are writing a container, you should have a definition that what that particular container does, okay, where it will be, uh, where that container will be stored, in which Docker platform will it be stored, who can manage it, for how much time will it be stored, what kind of process it will do, will it have any association with any other containers or not. So those kind of things, those kind of text parameters that you write within the within a script is called as a task definition. So basically, task definition can be written with the help of some Node.js. In case you know what is Node.js, so you can write that using a Node.js. So that is what is a task definition. This is my task definition, and this is actually the containers on AWS. So understand this particular thing. Now just see this. What happens is this is a diagram. This is a diagram about how the container looks in the cloud. On the cloud, when you are putting your container, how will it look? So basically, this is your ECS service, Elastic Compute Service, or Elastic Containerization Service, also you can call it. Fine. So you will schedule a task with the help of this service, and a cluster will be created. One cluster will be created in which there will be multiple containers. These are all different containers created in that. You can create as many containers in one cluster as possible. Suppose you can have 10, 15, 20, 100, 1000 number of cluster containers can be increased. That's why I told you that containers, I told you in the beginning, are super light technology. I mean, as we see that our applications are very heavy, they occupy a lot of space, they are like huge. Once you start making changes, application size starts increasing. But over here, our containers are a super light kind of application which we can create with having a dependencies attached to it. Next, we come on to the Kubernetes. So there is one more service on AWS which is called as EKS. EKS is your Elastic Kubernetes Service. So what is the difference between ECS and EKS? Understand it over here that Kubernetes is from Google. It's a open source container. It's an open source technology. Open source means for this using Kubernetes, you do not have to pay any money. You don't have to take any licenses. You don't have to, I mean, this is a free service which can be just taken from the internet, and you can start using. And Kubernetes is a managed service that you run on AWS without needing to install, operate, or maintain your Kubernetes control plane or nodes. And basically, Kubernetes is an orchestration tool. When I say orchestration tool, that means it is a management tool. So suppose you have created your containers and you want to manage those, because creating a container is not very difficult. Managing the container is a difficult, because when inside the Docker you have hundreds and thousands of containers created, so you need to manage them. Sometimes you need to scale them down, sometimes you need to scale them up, sometimes like you do with an application, that you want to change that application, update, modify, delete, take it away. So those kind of things. So Kubernetes is open source and orchestration tool by Google. It's a free service, but AWS is providing that on their platform. So over here, it's a managed service. Managed service means it's being provided by AWS, and you can used to run your Kubernetes. So suppose your containers are already running on some Kubernetes uh, framework, so you can just bring that into your AWS cloud and you can start working. All right. So you know about this Kubernetes, and this is the orchestration tool. So when you say when and where, so where it is used for orchestrating. It is used for managing your containers. Next is your Amazon Elastic Container Registry. So we talked about ECR, which is a container registry, which I told you that it is a fully managed registry service that makes it easy to store, manage, share, and deploy your container images. So I told you about the immutable images, that whenever you are creating containers, you will be creating a container, but that becomes actually a read-only image. So once you have created your software, executable software, that will not be deleted by anybody else. You can manage. So what is a registry? It is basically a service that will be able to store all the images. Whichever images we are creating, we can just store all those images in the ECR. So we'll come to that also in the hands-on session. So now we again see the difference between EC2 instances and Fargate. So as I told you, EC2 is a virtual server. Virtual server means that once you are creating a containerization tool, you can have a server below that which will be managing the entire, which will see what kind of space is being utilized by the entire containers and the Docker platform and the containers and everything. But suppose you do not want to get into this hassle of creating a virtual server, you can have a serverless technology which is called as a Fargate. So just read it out that for EC2 instances, it's saying complete control on the compute platform. That means if you want to have a complete control, you want to control the server also, the container also, the Docker also, so then you can have a EC2. But suppose you do not want to provision for that complete control, so then you just want to do the management on the container, so you can just go in for Fargate. And just to tell you about the cost per se, so this is a heavy cost and this is a low cost option. Billing is based on the cost of the underlying EC2 instance, and this is pay for the resources that you have used. So basically, the number of server that you will create, the type of server that you will choose, all those things will count as a part of your billing state. And you can increase or decrease the capacity. And over here, it's an improved security, or already it's an improved security. So over here, if you want the server to become smaller, later on you want, okay, I want a bigger space, so I'll start increasing my number of servers. Suppose you want late few days later, you say, okay, no, I want to remove few servers because it is costing you too much. So then you can remove few servers also. So this is the difference between your EC2 and Fargate. Now, talking about the advantages, I told you that first of all, I told you that the first advantage of containers is that it is super light, it is super durable. That means you do not have the headache of always running your application on a guest operating system, I mean, on an operating system. You can just write an executable, put it on any kind of an environment, prod, staging, your desktop, your laptop, anywhere, and it will start running. Second is that it is a reliable, it is very, very reliable kind of a process in which you can be, you do not have worry about whether my application will run on that particular platform or not. Will there be any kind of association? I will have to create new environmental variables, or I will have some runtime issues. So what if the version does not matches with the test environment and the prod environment? So these kind of things do not happen with containers. Next thing is security. So once you have created your container application and you put it on a platform, a Docker platform, your Docker is already very secured. So you do not have to worry about the security part that somebody will hack your application, or it could be somebody can manipulate with their application. It can be I mean it can be decrypted and used or some kind of those things. So these are some of the advantages. So we just see here in this. So basically, first advantage of containers is it is a security. So your application is secured when you create it as a container. It is reliable, that you can just rely that okay, once you have created, it will be working on the different environments also. And then you have choices. You have multiple choices, like where do you want to run? You want to run on a prod environment. You want to run on a different environment, any environment you want to run on, Unix, Linux. So wherever, whatever you want to do, you have multiple choices of running your application. And one more important thing, which is a very important aspect of cloud, it is deeply integrated. So deeply integrated means like you can integrate your application with various other AWS services. Like what do you mean by services? So suppose I want to have a IAM service involved into my container. What is an IAM service? It's a identity access management. That means I want to give a username and password to my container service. I say, okay, this is my container. I want this username and password. So whenever I am managing this through Kubernetes or the AWS services, I know that, okay, this is the username, this is the password. So only I am able to manage. So you can integrate it with different AWS services. There are multiple services in AWS. There are almost like 250 services now. So you can integrate it with different services. You can give it permission. You can say, okay, my container is only seen by developer team of my company, not others. And you can say that, okay, my container is will be I mean, this has some kind of permission you want to give it. That okay, it's a read only, on write only, or updatable, or not non-updatable. So these kind of integrations you can do with your AWS services. This is called as deeply integrated. So you can choose one service. You can say, okay, my container is allowed to be a part of the CI/CD. I can use it in this code commit. I can use it in code build. So those kind of integrations you can do with your containers. That means your container, once you've created your container, you are not alone. Like, okay, my container is created. Now what do I do if I want to, if I want to use this same application in a different project also? So do I create it again? No, I can integrate it over there also. We have command line interfaces, and we have REST APIs with the help of which we can do that. All right. So fine, I just want to show you hands-on also before we leave. So what are the use cases for containers? So what do you mean by use cases? Basically where it is being used. So the different use cases are microservices, because I told you earlier also, I started with this, that your containers are basically nothing but a small processes, small processes. And a big application you create, you just chuck it down into different pieces. So those kind of smaller pieces are created, and every piece is executable. It's not like you have to again join it and only then it will be working, because every piece has associated it has embedded runtime environment variables, bins and libraries has been already embedded into that particular chunk. So that's why what we call as microservices. So over here, the first and foremost, the most important use case of container is microservices, and then it is batch processing, and then machine learning. All right. So these are some of the use cases, and also you can use some hybrid applications, and when your application is migrating to cloud, that time also you use containers. Now we'll come to the hands-on. So I'll show you how do I create a container. All right, so I come to my console. So basically this is my console, and I've already created my username and password on Amazon console. So I'll go here and I'll search for the service ECS. I'll search for the service ECS. All right, Elastic Container Service. So I'll go there. I will click here. Fine. So this is my Elastic Container Service. So this will allow me to create containers in my Amazon. I can create a container with this. So just to give you a mm, good small background, that you can run containers at scale. That means I told you that in one Docker platform you can have multiple containers. That is called having containers at scale. Then it's a flexible container placement. Like you can just place your containers wherever you want. That is why you need Kubernetes. That is why you need orchestration. Fine. So flexible container placement and integrated and extensible. You can integrate. You can let the container know that which container will integrate. Like C1 will integrate with C2, or C1 will integrate with IAM. So I told you that it is deeply integrated technology. Fine. So those kind of things you can do with that. So fine, we'll get started. I have some questions. I'll just take it later on. So this is the first page. It says this is the diagram of your container. You have to have a container definition, a task definition, service, and a cluster. So this is a container definition. There are certain things which are already being given. We'll just use the sample only. So basically it's saying choose an image for your container below to get started. So what kind of an image? I told you that immutable images, the read-only images, that whatever in container you'll create, an image is created. And that image is stored where? It is stored in the repository, ECR. Remember that? So it will create an image. Why it is creating an image? Because it is my image. I don't want people to get, play with that particular. So I'm just choosing one image. I'll choose this sample app. Fine. And you can do editing over here. I mean, suppose you want to make certain changes, you can just do see, you can just do edit, and you can change the name, you can change this uh, image name, HTTPD, this, you can say private repository authentication. So suppose you want certain authentications, so you can say, okay, I want the authentication of a username, password, and all those kind of things. So you can make some changes. You can change the memory limits, like 512 to 1024 or something like that. So I'll not change it right now. I'll just use it as it is. Fine. Task definition is, what is the task definition? This is actually uh, is a blueprint of your application, describes one or more containers through attributes. So basically, I told you the task definition contains like, what is my container doing, who will update it, until what time it will remain, is there any expiry date or not. I mean, those kind of things will be defined in a task. So basically, you can edit this also. First time task definition, this is the task definition. I can change it, I can change the name. Okay, so it's saying network model, task executable, compatibility is Fargate. So over here it is using Fargate, it is not using that EC2. So it's a serverless technology. So you can make changes whatever you want to. I'm just using the sample. So I proceed to next. Fine. So it says these two things are done. My container definition is done. My task definition is done. So now it is saying you define your service. So services, a service allows you to run and maintain a specified number of instances. I mean, that means like in that service, how many instances of your container will run. So these are the things which you can make again changes. You can service name, you can make, I think we can call it as Edureka service, maybe 123, something we can call it. Okay, and it's saying network access. What is the networking you will need? Do you need some IP address or not? Which port it will run? Do you need any load balancer? So you must know what a load balancer is. All right. So what is elastic load balancing? I think you know this concept of load balancing, because whenever the traffic is too much on a web service, so that time you want to load your traffic, balance your traffic. So that time we create load balancers. So I'm not creating any load balancers, because this is just a sample this thing. So I'm just saying I do not want any load balancer. However, you can create that. Fine. So I go to next. All right. So I have changed the name of the service. I just made some change, and now it is saying configure your cluster. So what is the name of the cluster? Suppose I want to write the name of the cluster as cluster 123. Will it take? Okay. And it is creating a VPC ID. So you must be knowing what is a VPC. It's a networking term. VPC will be created, subnets will be created, and I'll go to next. All right. So now it says your container is done, your task is done, your service is done, and cluster is also done. So now all these things are done. If you want to still make certain changes, you can click on edit and make certain changes and go ahead and say create. See, it's started creating. These are the ECS resource creations. Cluster name is cluster 123, task definition, and see, this is all working. See, all is like it's revolving. It's, and some ticks are already given. Green ticks are already given. That means those kind of things are complete. So it says we are creating the resources for your service, and it may take up to 10 minutes. So this will take some time to be completed, and once it is created, it will start. Then we can see what happens there. All right, so this all has been created. My cluster is created and everything has been created now. So I go back to my service and I see that my cluster has been created. I mean, where will it take me? All right, I go to ECS again. and I see that my cluster has been created. You can see that cluster 1, 2, 3 has been created, and this cluster is created, and it's created on a Fargate. That means a serverless technology. There is now one service, one running task, and CloudWatch monitoring. I mean, there is a monitoring service which has already been started. So this is a default monitoring which has started. So and it's not been created on EC2, so it's saying 0, 0, 0 over here, and 0 container instances on this place. So now what I can do is I can also delete this. Suppose if when I do not want it, so I can delete it. I'll just click here. It will open, and I'll say delete cluster. So it will say, please enter delete me. So I'll say delete me and delete. Now it's saying deleting can take few minutes, so it will start deleting it. So this is how you create your cluster, and this is how you delete your cluster when you do not want that. Okay, so now you know the diagram. Now you understand that containers are inside the Docker, and that particular container remain inside the cluster. Like I showed you the diagram also earlier. So inside the cluster there are containers, and for those containers there are task definition, there are services, and different kind of things which make it work. And this is how it works. It will take some time. All right, class, thanks, bye, have a nice day.